welcome to this video. In this video, we're going to talk about how to perform a one-way ANCOVA in SPSS. So in this data set, we have three variables: stress, which we're going to use as our outcome variable. So we're going to predict stress. And to predict it, we're going to use the group, and we're going to use age. So the group is called the factor, or it's called the group predictor. And the fact that we have one group variable means that we have a one-way ANCOVA. And it's an ANCOVA because we have a covariate here, a numeric variable, which is age. So to perform a one-way ANCOVA, we're going to click on Analyze, General Linear Model, and Univariate. I'm going to reset everything. First off, you want to specify which dependent variable you have. We're going to select stress here. We want to predict stress here. Our fixed factor is going to be the group variable. And the covariate is going to be age in this case. So in other words, we study the effect of group on stress, controlling for age. Let's look at the model first. So by default, the model that is created is so-called full factorial. What it means in this case is that we have a main effect of group and a main effect of age, meaning that in fact we have in this model no interaction by default. We could add it, but we're first going to look at a model without the interaction. So if we keep with this default model, we actually will have two effects: the effect of group and the effect of age, and also an intercept. Because there's no interaction, doesn't matter if we choose type 2 or type 1 sums of square here, which are the main ones we want to use. So let's keep it with type 3 in this case, and we'll click continue. I'm not going to look at the contrast because there are only two groups. We're going to look at plots and see what we can do here. So typically in this case, because we have one group factor, you typically want to see a graph where you have the means of the outcome variable, stress, as a function of the group variable. So we're going to use on the horizontal axis the group, and I'm going to add the plot over here to the list of plots to create. And that's in fact the only ones we would want to create in this case. We're going to keep a line chart, and we're going to select error bars, and especially usually we report confidence intervals rather than standard errors, but both are possible here. So I'm going to keep confidence intervals and click continue. Here we might also we might want to see the estimated marginal means in the plot as we've specified before, but we might want them in a table. The way we would do that is we would click on EM means for estimated marginal means, and we would select the group here variable to show the means by group. If we want comparisons of means rather than just the means themselves, we could also check this box, but we don't really need it here. I'm going to click continue. I'm not going to save residuals, but we can save residuals by clicking on the save menu and checking, for example, the residuals here. For example, that could be used if you want to test the normality of these residuals afterwards. So if I check this and then run the model, it's going to create a new variable here. So I'm not going to do it here because that's a bit beyond the scope. I'm going to click on continue. And finally, I'm going to click on options. And the one I especially want to check here is I want estimates of fxi. So I want especially the partial eta squared measures of fxi's for each of the effects. Okay. I'm going to click on continue, and let's look at the output. So here we have some really basic information with just the group sizes, but most of the important things are here. So first off, here the first line with corrected model is essentially an F-test of model fit. So we have a significant model fit. And here is its partial eta squared, which actually is equal to R squared in this case. And the only issue with that is that it confounds the two effects. So it confounds the effect of age and the effect of group. Usually we want to study only one of them, or study them separately. So here what we want to look at is the effect of group controlling for age. So to do that, we would look at the line with group. If we wanted to study the effect of age controlling for group, we would look at the line with age. But here we want to study the effect of the group controlling for age. So we're going to look at this line over here and see that actually we have significant mean differences controlling for group, controlling for age, because we have a p-value here below 0.05. And here we have measures of effect size. Since we asked for them, they are reported in this column. If we scroll down, we have here the estimated marginal means. So what it does essentially is it computes the predicted means. And to do that, because we have different levels of age, it actually fixes age to its mean, which in this case is 59.95. These are the estimated marginal means with their standard errors and confidence intervals. If we want a plot of these, so it's exactly the same thing, but as a plot, we have the plot that's reported here because we asked for this particular plot. So now the last thing usually we want to do is we usually want to check to see if there is an interaction between age and group, which we haven't included in this model. And often this is called testing the homogeneity of regression slopes. So we're going to test an interaction. So I'm going to recall the same analysis here, univariate. It's going to give me the same menu. But now I'm going to click on model and I'm going to specify terms manually. So I'm going to click on build terms and then I'm going to select my effect. So I'm going to select the group as main effect, age as main effect, and finally I'm going to add an interaction between group and age. So I'm selecting interaction, selecting the two variables, and I'm clicking here on the arrow and you see I have age by group. Now, if I choose type 2 or type 3, it's going to change the tests for these two effects. But in this case, I just want to test the effect of the interaction, so it doesn't really matter. I can keep type 3. I'm just going to test the effect of the interaction anyway, which would be the same for type 2 and type 3. So I'm going to click on continue and look at the output. And what I want to look at here is I want to look at this added term, which is group by age. And so in this case, it's non-significant. So there's not a significant evidence that there is an interaction between group and age. In other words, we can still assume homogeneity of regression slopes, meaning that it's reasonable to use the model without interaction in this case to study the effect of group controlling for age. That's it for this video. Thanks for watching.